There you go. I could see. Yep, looks good.
All right, perfect. All right, so I can't see the chat now, Julie, but if there's any questions, yeah, please feel free to interrupt, and then I'll take up those questions.
It's fine. So any questions, please put them in the chat.
Got it. All right. With that, yeah, thanks, Julie, for the opportunity to speak. Thanks for setting this up. So we'll get started. I know in the title we talked about Azure resiliency for high availability and resiliency for applications, but I kind of updated the tag to include both HA and DR because both of them go hand in hand. My name is Rajesh. I'm a principal product manager in Azure SQL DB team. I've been with SQL for close to 15 years now. Been at Microsoft for more than 10 years. Started my career as an Oracle DBA and then switched to SQL Server DBA within Microsoft. I was doing multiple roles within Microsoft, starting with CSS, then on consultancy, and then moved on to CAT teams, and then landed in the SQL DB PM team. My current area of focus is on SQL DB high availability and disaster recovery, and all things associated with it. Some of these things are customer-facing features. Some of these things are service fundamentals, NHA and DR aspects. All right. With that, let's quickly get into the agenda aspect. Today we'll be covering a brief overview of business continuity. I know everybody understands what business continuity means, but we'll quickly refresh our concepts here. Then we'll go deep into availability, high availability, and disaster recovery. So there is a big education that we want to do from the product team side to field, and then to people who are on customers and field resources, where we want to do a better job of breaking down how do you think about availability, high availability, which is commonly referred as HA, and disaster recovery, which is DR. So we'll touch a brief, good amount of time on that slide. Then we'll talk about various architectures of availability and high availability. Some of these things are good to know, but it also gives you an understanding of how things happen behind the scenes. And in a PaaS service, the onus is on the service provider, so which is on Microsoft, but we want you to make sure that you understand the architectures that you're dealing with. Then we'll touch upon disaster recovery architectures as well. And towards the end, we'll also look at some key takeaways. These are resources that we have published out in the docs. Some of this has been learnings that we have heard directly from customers. So we wanted to make it really simple, prescriptive checklist on what the HA and DR aspect should be. So that's how we created this HADR checklist. So we'll go over that in detail. And we also want to talk about the outage recovery guidance, which is again based off all the learnings that we have seen from customers. We have synthesized that and published in the documents. So we'll go over through that. So if there are key takeaway, I mean, if there is something that you want to take away out of this meeting, then focus on those checklist and the guidance that we put it in the docs. All right. So with that, let's quickly refresh our concepts on business continuity. I know everybody understands this, but in reality, what happens is we land into various situations. Some of these are as customers deal with their applications and data. There are situations where customers inadvertently delete records, or they land in situations where somebody ran a select query without a where clause, and they need to go back in time. So that's when the restores come into play. If you take out the backup and restore story, which is on the leftmost customer errors scenarios, the thing that is most common in a cloud world is all the failures that happen at multiple layers as we operate cloud at a scale that we are operating. So with the hyperscales, what I mean by hyperscale is all this public clouds that we are offering. The number of failures that you see at various layers, I mean, it could happen, the failure could be at a software layer, it could be at a hardware layer, it could be at network layer, or anything in between. And you might have heard this notion where it is meant to, I mean, you will see continuous failures at every layer. What we need to do as service provider is how are we absorbing those failures, how are we reacting to those failures, and making sure the service is resilient to those kind of failures. We have come a long way. We are still learning as we make changes to the service, as we expand the service, as we meet to the scale demands of the customers who are pushing the envelope on the service. And then there are the natural disasters or man-made disasters. Think of these as scenarios where which is outside our control. any kind of natural events, like let's say a flood or a tornado wiping out an entire data center, and how do you react to that, right? There are situations where you could be deployed to a particular region and the entire region is kind of facing the impact, or it could be a subset of the region, or it could be just one zone that is getting impacted. But then you can architect your database in a way or enable certain configuration options wherein your database is transparent to those kind of failures. So we'll talk about those in depth here. All right, so with that, let's get into the key concepts here. So one of the things that we want to, as I highlighted in the initial introduction, the understanding that we want from a product team that we want to share with customers and folks like you is there are three notions, which is availability, high availability, and disaster recovery. So availability is something that is the off-the-shelf feature for a database in a PaaS offering. So when you come to a PaaS offering like Azure SQL DB, and then you say, I want to create a database or you provision a database, we guarantee that this is part of the core offering, which is the core resiliency and availability guarantee that we provide. And this is something that as service provider, we take it on us. We are also backing it with financially backed SLA. So which means if there are SLAs, if you don't meet that 4.9 SLA, you can always call into the support and then get the service credits based on the SLA numbers that we have published, right? And the two key concepts in HA and DR are RPO, which stands for Recovery Point Objective, which is nothing but data loss, and RTO, which is recovery time objective, and which is nothing but downtime. So in case of high availability, we guarantee that there is absolutely no data loss because that is something that we guarantee off as an off-the-shelf feature. For the recovery time objective as the downtime, we strive to achieve zero, but there are instances in real world examples where this could be more than zero, or it could be very close to zero. In some cases, it could even be higher. That's when we say, hey, we have a financially backed SLA, so you can always leverage the service credits that gets promised as part of the SLA offering, right? So this is a feature. So this is an aspect that is completely owned by us. So as service providers, we have to guarantee the availability for a SQL database that any customer would provision. All right. So with that, let's get into the second concept, which is high availability. Pretty much what I've seen in the industry is we have converged into this notion of high availability for a database, uh, being analogous to creating the database in a zone redundant fashion. And this is a customer configured option, which means as a customer, you have to turn on a knob to go from availability to high availability. And the reason why the industry or pretty much every cloud service provider has converged onto this concept and this definition is in high availability, what we do is within a region, you have multiple availability zones. I know everybody might have dealt with availability zones, but just a quick refresher, these are independent, isolated data centers within each region, all within a safe network round trip latency. So that way, each availability zone will have its independent network, power, cooling, deployments, or the infrastructure services that each data center within the availability zone gets. So that way, if there is one outage that is impacting a zone one, let's say in this example, the other two zones just function as if nothing happened. And this is guaranteed at multiple layers. So it is guaranteed at the control plane layer. It is guaranteed at the data plane layer. What I mean by control plane is, let's say you want to create a database, you want to read a database, you want to update a database. So these are all the control plane operations. Let's say you go and start a failover of it, or you update some metadata of a database. So these are all control plane operations. And what I mean by data plane is the SQL Server data, which is in the data file, the MDF and LDF. So we make sure that the data is replicated across all three zones. Technology is something that we'll touch upon in subsequent slides, but it's our responsibility to make sure that data gets replicated across three zones. So that way, even if one zone is out, gets impacted due to an outage, it's transparent to the application. So that's the key understanding for high availability. And we also guarantee higher SLA because now that we are resilient to a larger set of failures, we go from 4 nines to 4 nines and a 5. Right? So that's again an industry-leading availability guarantee that we provide. Similar to availability in HA case, there's absolutely no data loss. That's something that we guarantee off the box, right out of the shelf. And in terms of downtime, It is close to zero. It's sub-seconds because there is some kind of failover involved, which we'll understand deeper in subsequent slides. But it's again, the goal is to make sure that the downtime when any of the zone goes down is again close to zero, right? With that, let's get into the third pillar of business continuity. So the third pillar is disaster recovery. This again, as you might have guessed, this is again a customer configured option. So this is a scenario where you would prepare, let's say, let's say you deploy your primary region into East US and all your deployments are into that East US region. But you want to have this coverage where what if the entire East US region goes through an outage? So you will need an ability to fail over to another region, which means you need to have a disaster recovery region set up. So that way that will become the secondary region. And if things go wrong in the primary region, you always have a capability to fail over. And this comes in multiple layers. So SQL DB is just one part of the application. You will have other moving parts for your application, other dependent services in your application stack that you might have to replicate from the primary region to the secondary region, right? And this provides the maximum protection for your application, right? Because you have your availability, you have your high availability, and you're also guaranteeing that in case the region goes down, you still have a secondary region to fail over to, right? And the recovery point objective, which is data loss, since we are dealing with two regions, which are geographically separated by miles, depending on what region that you pick, East US to West US or East US to North Europe. There's so many constraints that every customer would have to go through in terms of the compliance and the geographical boundaries that they have to adhere to. But nevertheless, the idea here is since it is a region which is geographically dispersed from the primary, there is definitely an asynchronous nature of data replication. Uh, Doing synchronous replication at multiple geographies will definitely impact your write performance on the primary. So that's why it's always an asynchronous nature. And with that comes in some amount of data loss. So there is some amount of data loss as you're dealing with disaster recovery, but it's definitely a quicker, higher business continuity wherein the application's availability gets restored without having incurring a lot of downtime, right? And in terms of the actual downtime that it takes, let's say if you have to do a failover between your primary and secondary, it's typically greater than zero in the single digit or double digit seconds, depending upon how much of activity was going on at that point in time. So it's kind of a variable. There's no way we can tell how much of a downtime that you would incur irrespective of the application workload. So it's definitely a workload dependent factor. All right. So with those three concepts or three pillars that we talked about, there are two dimensions that you think about these three pillars. So one, as you go from left to right, your price definitely goes up because you're going from availability to HA, which means you are creating multiple copies of the data within the same region. So definitely there is a higher price. And in one of the SQL DB service tier, which is again, I put it a star here for BC and premium service tiers. I'll talk about that in the architectures. We offer it for free because of the architecture that we leverage. But in general, as you go from left to right, the price goes up, right? As it's expected, because in disaster recovery, which is kind of an insurance policy, there's definitely some kind of a higher price that you pay to have deployments both in primary and secondary region, right? But what you get at the other end is the business continuity, which goes higher as you move from left to right. Right. All right. So these are the two concepts that we want to drive across from product team, and we want to make sure that customers understand these two concepts, right? In terms of price, business continuity, and the three pillars that you deal with in business continuity. All right. So with that, let's quickly understand this in terms of some animations. So this is what happens in an availability scenario. Uh, Imagine each dot is a replica of the database. Imagine this is a business critical database. In availability, we make sure that we place these replicas across nodes within a data center. So here the rectangle here shows a data center, and we place all of them within one data center. In HA, what we do, which is again zone redundancy, we place these replicas across multiple zones. So that way, if one of the zone is going down, the DB is resilient to zone failure and it will be transparent to the application. So the application doesn't even know that a zone went down and you will still be available without any kind of hiccups, right? In disaster recovery, we look at different regions. So what we do is you spread it across in zones within the region. That's for HA. And then in DR, you replicate this data across regions, and then you pick a different region where you send all the replicated data to. All right. With that, let's quickly look at some architectures for various service tiers. So one of the things that we offer in SQL DB, we have three different architectures. One is the general purpose and standard, which is based off of remote storage. Then we have the business critical. This is for applications which need extremely low latency. And then came along the hyperscale, which is a completely cloud native architecture. It decouples compute and storage, so that way storage can auto scale. And then it has this nice benefits of compute going up and down within seconds, because we have decoupled compute and storage. So you can scale up, all the scale up and scale down operations are much more instantaneous. And we'll touch upon architectures on these three flavors. If you look at the general purpose and standard, think of this as very similar to your failover cluster instance, as in you have a primary and secondary. Everything is online on your primary. If something goes wrong, it automatically fails over to secondary. So if you have that understanding, understanding the remote storage architecture, which is in GP and standard, should be fairly simple. So you have your primary replica. We stored the data on the premium storage, which is again locally redundant storage. And then the backups are stored in Azure storage, which is again geo-redundant storage. So that's the default redundancy type that we choose for backup. And what we do for availability is, if any of this node goes down, so we do have nodes with spare capacity. So that way the compute actually fails over to the healthy node, and then the files get reattached and your database becomes available. And all of this orchestration is happening under the covers by Service Fabric. So that's something that you don't even know about it, and you don't have to worry about it. This is something that we take care under the hood. There's no change in application connection string. Everything remains the same. You just reconnect to, if you have a retry logic, you just connect to the healthy compute node and you'll be back up and running. Right now, if you look at the same general purpose remote storage architecture and then look at a high availability aspect, let's like how do we guarantee zone redundancy for GP? And this is only available in GP, not in standard. But if you look at the architecture, what we do is we switch from the locally redundant storage to a zone redundant storage. So the data file and the log file for the DB, they get placed on ZRS storage, which means they get replicated across three zones. Azure Storage always has three copies of data, and it stores each copy of the data in each of these zones. So any write that you do is synchronously copied across three zones. So that's how we guarantee zone redundancy at the data layer. For backups, it's an option that you can still choose with GRS, or you can choose the zone redundant storage depending on what needs that you want to meet. Right. So that's on the data layer. Now, what do we do for the compute layer? For the compute layer, we make sure that we have additional spare capacity in each of these three additional in the remaining two zones. So that way, if zone one gets impacted, our orchestration layer, which is Service Fabric, we tell Service Fabric that, hey, you have to fail over the compute to one of the healthy zones and make the DB available, so that way customers don't have any impact when a zone goes down. So that's how we guarantee HA for general purpose service tier. So this is resilient to zone failures, and we guarantee higher SLA. I want to quickly touch upon the number of regions where we were available. We initially started off with 4 regions because of our dependency with a specific type of storage type. We in the last 6 to 8 months, we have expanded this to pretty much most of the heavy hitting regions. So we went from 4 to 14 regions, which is kind of very good news, because I keep getting a lot of pings from customers and from our support, as in customers asking us, when are we expanding this to additional regions? We have gotten to 4. We still have some additional regions to cover too, but at least we have the big regions where our biggest SQL DB deployments are available. So definitely encourage customers to leverage the high availability in the GP tier, so that way you can be more resilient to a larger set of failures. Right?
Rajesh, we've got one question.
Sure.
It's can an organization schedule a test of the failover capability?
Yes, you can. Yep. We'll talk about it in the HA checklist, but yes, you can, and we actually expose an option, a short PowerShell command that you can do it. All right. Any other questions, Julie? I know I'm not able to look at the chat, but not
No,
I'll
that's
just
it.
Okay. All right. Also want to highlight that for general purpose tier, since we reserve spare capacity for the DB in the other zones, there is some amount of surcharge that we charge. So on the compute, you will see some amount going up. So definitely encourage you to look at the pricing calculator, see the additional cost, but we want to be very transparent with the cost that it incurs. Obviously, as I said in this initial slide where we talked about three pillars, to get to high from availability to high availability, there is some additional cost that you incur for some of the architectures. All right. So with that, let's go to the second architecture that we deal with, which is business critical and premium. So these are extremely useful for applications that need extreme low latency. And the reason why we are able to guarantee that is we completely leverage the local SSD, which is pretty much on the physical node. So we place the data and the log on the physical node. So that way, that's how you get the extreme low latency for log writes and for applications which are extremely chatty and they need that higher and they need the higher throughput and low latency for the reads, right? The way we guarantee high availability for business critical and premium service tiers is based on always on topology. So if you understand always on in the on-premises world, it's exactly the same thing that we do even in the SQL DB cloud world, right? We guarantee there are multiple replicas. We guarantee that when data is written, at least it's get committed into one of the secondaries before we send the ACK back to the application saying the writes have been completed. Data is placed on the local nodes. Backups still go to Azure Standard Storage, and you have the option to pick any redundancy type that meets your requirements. And automatic failover happens if, let's say, if one of this node goes down, we automatically failover. This is always on, and then on top of it, we do have Service Fabric that does the orchestration. No change in connection string, everything just works as is. Since we have multiple replicas here and multiple copies of data, we also expose this option of read scale-out. As in, when you from the application, if you say if you pass in a connection string which says application intent equals read only, we route you to one of the secondary replicas, and you can use one of the secondary replicas for reads. So that way you can scale out your reads and then offload some of the workload from your primary. And since we already have 4 replicas anyways, and customer is anyways paying for the business critical and premium service tier, there is no additional charge for read scale out. So this is something that you get for free. Right. Now, when you look at a high availability architecture for BC, which is business critical and premium, the way we guarantee zone redundancy is we spread these nodes across multiple zones. So as you can see here, think of this as a ring which has the multiple nodes, and then we place these nodes in multiple zones. So that way, if a zone is going down, you're still resilient to a larger set of failures. Backups still go to standard storage, and you can choose the redundancy type. And this is one of the service tier where we even expose high availability at absolutely no cost. As I said, since the architecture already has 4 replicas, and it was just a placement logic that we had to tweak on our end to place these replicas in multiple zones. So we don't charge anything extra for high availability in BC. So if you're on business critical and premium, so it's an absolutely no-brainer to enable zone redundancy for these databases because it doesn't incur any cost. Obviously, you'll have to do your functional test and the performance validation test to make sure that there is no additional perf hit because now data is getting replicated from one zone to another zone. These zones definitely there is some amount of network latency that you hit, but most of the application should be absolutely fine with it. But definitely encourage you to do a perf test before returning on that knob. And obviously the SLA goes up because we are doing now we are resilient to zone failures. So we go from 4 nines to 4 nines and a 5. All right, so with that, let's get into the third service tier, which is the hyperscale architecture, completely built ground up for cloud native architectures. So there are a couple of moving parts here. So one is the compute layer. So right at the top is the compute layer, which is where you connect to. So when you create a hyperscale database, you get a connection string, and when you connect to it, this is where you hit. I mean, this is where you interact with. On the compute, you can still have some secondary replicas. You can go from 0 to 4, which is what you can do it at the compute layer. And down at the bottom, the compute layers talk to page servers. Think of these as let's say I'm giving you an example. I mean, I'm oversimplifying it, but think of this as the data file being broken down into multiple chunks of data. Each page server is responsible for some chunk of data, and it has its own start offset and end offset. So this page server knows exactly what are the pages that this page server is going to serve. And as you can see here, the paid page servers, the one behind it and one in the front, these are again making sure that there is redundancy. One of the page server goes down, the redundant page server will take over. So that's how we guarantee resiliency at the page servers layer. Down at the bottom is where the actual data resides. So as you create a hyperscale database, uh, the the actual data file sits in Azure Standard Storage, but what we do is we again cache it into the page servers, and from the page servers is where data gets served to the compute layer. And what about log? I mean, which is where all the writes go to. So we separated out log service as well, so that way log service can independently scale. Uh, in hyperscale, we do get every database gets 100 Mbps of log generation rate. So which is very neat because irrespective of the compute size, you get to have a log generation rate of 100 Mbps. And as logs get generated, the log service is the one that will make sure that all the page servers get caught up, or the secondary computes which are available, they get caught up on this. So it's a log service that feeds all the replicas in this whole topology. Backups again, we use snapshots, so snapshot level backup, and then these are again based off of the redundancy type that you choose for the storage for the database, and all of this is orchestrated by Service Fabric. So if compute goes down and if you have one of the secondary compute, we just fail you over quickly and everything just works fine. So this is the architecture for resiliency for hyperscale database. Now, what happens when you enable zone redundancy for hyperscale? What we do at a high level concept is we make sure that at each of these four components, which is compute, page server, uh, Azure storage, and the log service, we make sure that the, the replicas are spread across multiple zones. So as in at the compute layer, we make sure that you have a primary, which is in one of the zone, and then we mandate you to create HA replica. So that way the HA replica can be placed in one of the different zones. So you will have redundancy across the zones. We do the same thing for page servers. Uh, so all the page servers, like in this case, the blue boxes here, these are redundant page servers, and we make sure that we place them in multiple zones, so on and so forth, depending upon the size of the data. And for the Azure Standard Storage, we switch from the local redundant storage to a zone redundant storage. So that way, every copy of every data that's being written is written into 3 different zones to guarantee resiliency across the zones. And same thing we do for the log service too. So we make sure that we place these log service replicas into multiple zones. So that's how we guarantee resiliency on the log service. So this is something that we GA'd less than a year ago. We GA'd in August of last year, and we want to make sure that customers leverage this. So this is one of the neat options that will help you to make sure that your hyperscale databases are resilient to zonal failures. Uh, and this comes with an additional cost in terms of as we enforce primary to have a HA replica. So there is some additional cost, but we also discounted the HA replica cost at a Azure hybrid benefit price. So this is definitely much cheaper than a full-blown replica that you would have otherwise paid. So there's some amount of cost optimization that you get off the box. I'm sorry. Uh, this is something since for the hyperscale architecture, we completely rely on Azure Standard Storage down at the bottom for the persistent data file. This is something that is set when you create the database. So when you create a database in a non-zone redundant fashion and you want to enable zone redundancy after the fact, so today there are a couple of options. So you can create a database copy or a point-in-time restore or a geo-replica, depending on how much of downtime that you can incur to convert an existing non-zone redundant database to a zone redundant database. It's our inner backlog where we want to make sure that this operation of switching back from zone redundant DB to non-zone redundant can happen on the fly, but that's something that will be picked up as we get to that work item in our backlog. All right, I definitely touched upon various concepts on the HA. Just want to quickly check, Julie, if there are any questions in the chat that I can address.
No, you're doing fine.
All right, thank you. All right, I hope that gave you a good perspective and understanding of what happens in various service tiers for availability and high availability. Let's quickly switch gears and touch upon disaster recovery aspects. So in disaster recovery, as we talked about, this is cross-region replication. The name disaster recovery actually signifies that if there's something happening in a primary region, you do have a secondary region to fail over to. So this provides redundancy across zones, so your business continuity definitely goes up. Uh, there are a couple of different ways that you can configure disaster recovery for SQL DB. You have two options. So one is active geo-replication, which is at an individual DB layer. But if you have a group of databases that are all dependent, you can put them in a failover group. There are also some neat advantages with failover group, which we'll touch upon in subsequent slides. But think of failover group as an abstraction on top of geo-replication. It's just the same technology that we use under the hood, but we make sure that we do it at a bunch of databases that you put it in a failover group, right? And all these recovery options, they work at an individual database level. Uh, these databases can also be used. I've seen customer scenarios where customers use it for read scale. So let's say you have your application in East US and you have created multiple geo replicas in West US and South Central US. So you can have your applications route their connections, route the read activity to those regions that are closer to them. So that's something that you can manage using Traffic Manager or any other networking profiles and route them to the nearest region that you can send them to. So that way you can offload a bunch of reads to those secondaries. I've also seen customers use geo-replication as a mechanism to relocate their primary. So there are instances where customers, for various reasons, they have to move their primary deployment region from region A to region B. And the neat way to do it is using geo-replication as one of the mechanism to do the data synchronization and then do a planned failover. So that way there is absolutely no data loss when they do the switchover. Right, so these are some of the cases that I've seen customers exploring geo-replication for. Looking at the architecture or how geo-replication works under the hood, you have your primary logical servers, you have your secondary server, and then on a DB, you enable the active geo-replication. So that's how data gets replicated. And this is always asynchronous. And this is for reasons that we discussed earlier. Uh, since we're dealing with cross regions, it's always an asynchronous replication. Uh, and then you get an endpoint. I mean, you can connect to your primary, which is where you can do your read and write. And you can also individually connect to your secondary, which is where you can have a read-only queries being offloaded. And it's also in a region that can be intelligently managed and traffic can be routed to this if you have heavy read activity that you want to offload from your primary service, right? And for failover groups, what we do is it's just the same DB replication that we use, the geo replication at a DB layer, but we created this abstraction, which is again an ARM resource. What we do is we create a failover group resource and let you put a bunch of databases within the group. These are all dependent databases that you can failover as a group. And one of the neat advantage with failover groups is you get these two endpoints, which don't change depending on who the primary is. So irrespective of the failovers, these endpoints are constant, which means you don't have to incur any change in the connection string if you do a failover from primary to secondary or you fail back. These endpoints always remain unchanged. And this is one of the advantage that many customers see when they look at failover, when they decide between active geo-replication and failover groups. So that's something that you can leverage and avoid changing any connection strings. Quickly looking at comparing the capabilities between geo-replication and failover groups. One we touched upon, failing over multiple DBs together. So that's possible in failover groups. Automatic failover policy. So one of the advantage with failover groups is when you create this group, you can also delegate the failover policy to us. As in you can say, hey, if there is 1 hour of downtime, 1 hour of downtime, or if the outage lasts for a longer time, you can say, hey, fail over the failover group, and you can pass on that responsibility to us. And as service providers, we'll make sure that we fail over the failover groups at the set time that you have defined. So this is something which we call it as auto DR, wherein you set the properties for a failover group, and we take care of the rest when we see an outage that spans an entire region, and we determine that this outage has significantly impacted a bunch of DBs for a longer duration. And here are some failover groups where customers have delegated those failover responsibilities to us, and we make sure that we fail them over so that way you don't have to do any action on your side. And then constant endpoints, which are endpoints that don't change, the one that we just talked about. This is one of the features that's available only in failover groups. In terms of number of secondaries, we still have some parity gap. Today for active geo-replication, we support 4 secondaries. So that's 1 primary, and then you can have 4 secondaries for each of the primary. For failover groups, today can only have 1, but we are thinking what can we do in this area. In terms of having secondary in the same region as primary, this is something that we have seen customers do it for various reasons. If they want to offload some of the reads, but they want to make sure that the reads also read a copy of data that's real time to their primary, so that way they create a geo replica within the same region and offload the read. So this is something, one of the scenarios for read scale out. With failover groups, we mandate that your secondary has to be in a different region, and this is primarily for the DNS endpoint routing that we manage. So we make sure that you have the primary and secondary in different regions, and not both of them are in the same regions. In terms of hyperscale parity, for active geo-replication, today we support 1. We are actively working to make sure to close this parity gap for hyperscale. And then for failure groups, it has full parity. All right. So with that, let's quickly get into the checklist. So any questions here for HA and DR before we get into the key takeaways for this presentation? Julie, are there any questions that you?
Now, there was just one about how many replicas does the geo-replication allow with the Azure SQL database, and on the previous slide right there, it mentions 4. So.
Yep.
And then another one just came in. Would Azure SQL geo-replication failover group cause any performance impact? If so, what would be the impact?
Got it. Yeah, that's a good question. It's very hard, as I said, it's very hard for us to generalize the perf impact, simply because if I go back to the slides, these are 2 different regions. When you say performance impact, this is an asynchronous replication. So you wouldn't have any perf impact on the primary. We're just reading the logs, and then logs are sent over. These are asynchronous replications, so the primary doesn't even wait for any of the secondary acknowledgement. We just harden the log. The log hardening happens, and then the replay happens asynchronously. We don't wait for any of the acknowledgement from the secondaries to the primary because of the asynchronous nature. But what it means is it does mean that the secondaries will have some kind of replication lag, depending on how busy your primary gets and depending on how far away the secondary is from your primary. So these are two factors that would impact the performance on the secondary. What I mean by performance is the data freshness, and then how low the replication lag can get to. But a perf for primary, it's orthogonal, so we don't hold up any perf on primary if you're setting up geo secondaries. But there is also a catch wherein we highly recommend customers to create primaries and secondaries with the same size. What I mean by same size is, let's say you create a primary database with 4 vCore, and then you create a secondary database with just 2 vCore, which is a mismatched SLO. In those scenarios, we don't want to leave obviously secondary will struggle to catch up if there is a lot of activity going on primary. In those scenarios, you will see some perf impact because we want to make sure that the secondary is not left behind. So at some point in time, we'll make sure that the primary throttles the write to make sure that the secondary catches up. And the best way to avoid that is creating primaries and secondaries with a similar service level objective. So that way, both of them are at the same size to apply the law. Yeah, that was a long answer, but I hope it clarified a bunch of things. Julie, is there any follow-up question to that, or if there are any other questions?
That's it. Thanks.
That's it. All right. All right. So with that, let's quickly get on to the checklist. Let me go to the browser. OK, these are all published in the docs. I know there is a way I can get these slides too, so you can quickly get to the link. But I can also paste these links in the chat if that helps. Once I'm done with this talk, I'll paste these links in the chat so that we can directly get to it. These are published in docs. So if you go to the SQL DB docs, under business continuity, you have this HADR checklist. All right, so what does the checklist talk about? Let me zoom this in a bit. That makes it better. All right. One of the checklist is enabling zone redundancies. This is something that we talked about. So enable zone redundancy. This will make sure that the DB is resilient to larger set of failures. It's actually no-brainer for business critical and premium tier where you don't have to pay any additional price. So enable it in all the regions where it's available, so that way you can have higher resiliency for the database. The other advice, which is again consistent in any kind of cloud development, cloud-related application, is retry logics. So there are retry logics at every layer, and you need to consider incorporate retry logic for the database layer as well. So that way, if there are any transient failures, as we talked about in the availability and high availability, many of these are instantaneous, but it does also mean that the service gets restarted, which means the compute gets killed and the new compute gets spun up, which means the process gets restarted. So your existing connections do get dropped. So which means you will have to retry. So if you implement retry logic, those will be absorbed, and the application will be transparent to these kind of failures. The other way you can also achieve high availability or ensure you have higher availability is leveraging maintenance windows. So that way you can make sure that all the platform maintenance that we do, they happen on a predictable schedule. So you can schedule these maintenance windows so that way you are not the application is not interrupted with platform maintenance during business hours that are important to you, right? And this is something that I think there was a question. So you can also test application fault resiliency by leveraging these commands. Let me open these. So these commands actually give you a neat mechanism where you can invoke database failure. So this is something that you can definitely do as part of your testing, where you say, you want to test how does your application behave when there is a failure in the backend. And these commands do a great job of invoking those kind of failures. So you can simulate failures as if something happened in the data center. What we do is we fail over the compute from one node to another node. So that will percolate as connection drops for the application. So it will also see you can also see your retry logic being exercised. You can also verify if your retry logic worked as per what you expected. So these are neat commands that you can leverage to simulate failures. Yeah, so that's the checklist for HA. And in terms of disaster recovery checklist, we highly encourage enabling one of these two options, either a geo-replication or with failover groups, depending on what's your use case. Our preferred method is definitely auto-failover groups, because this is something that will help you to achieve failover for a bunch of databases. Even if you don't have a bunch of databases, you can still leverage the endpoints which don't change upon failover. This is such a it provides such a relief for the developers or for data engineers who manage databases in the PaaS environment, where they don't have to change the connection string or they don't have to ask the application teams to change the connection string. So this is something that's a neat advantage. One of the key point that I think we briefly talked about it is making sure that you create your primary and secondary with a similar size. So that way you avoid any kind of mismatches between your primary and secondary. We see this customers doing it for various reasons, obviously to optimize cost on secondary, but always make sure that understand that the lower your secondary goes, the higher the chance of primary getting throttled if there is a need. And when a disaster strikes, this is like an insurance policy, right? So you need your secondary to be caught up when you really need it. And if a disaster strikes, and you have to fail over, and your secondary is left behind, so you will take a higher data loss for scenarios where you might have otherwise not have taken if you had set up the secondary at the same size. So there are definitely a lot of side effects when you size your secondary to a lower one than primary. For cost optimization, it's something that customers do it, but I would highly encourage to reevaluate that strategy, because it'll bite you hard when you actually need the database to be failed over to a secondary region when it is disaster struck. So this is like an insurance policy, right? So you don't want to incur a data loss when you actually need the secondary database to be in sync with primary. There's also an option that we exposed. So this is for scenarios where you say, hey, I want to make sure that some of this data that's being generated on the primary, I want it to be replicated to the secondary in near real time. Meaning these records are these data changes are extremely important. I want to make sure that the secondary is always caught up with primary. So we do expose this command, which you can call from the application, where you can say, wait for the database copy sync to complete. it's an option that you can explore, but it's something that you don't do it right off the bat for all the databases. This is something that you carefully evaluate depending on the application needs. There is a side effect in terms of uh, whenever you call it, all your threads are waiting for this data synchronization, the logs to be hardened on the secondary. So there is an additional perfect that comes, but there's a trade-off. The trade-off you get is an availability of the data on the secondary as and when data gets changed on the primary, right? The other checklist that we also talk about is how do you monitor replication lag. So we do expose this column called replication lag seconds in this DMV. So this is something that we highly encourage you poll at a regular interval, and then you can get a sense of how behind the secondary is. This is one of the data that you get primarily on the primary server. So as data gets generated on the primary, the only way for us to know the replication lag for any geo-replication link is pulling this on primary, because primary knows at what log records have been sent to the secondary, what log records have been hardened on the secondary. As and when those log records get hardened on the secondary and the primary knows about it, the primary gives you an estimate of the replication lag in terms of seconds. So that way, if a disaster strikes at any point in time, you can estimate, let's say you see a value of 5, so which means you will lose 5 seconds worth of data. So that's something that's a good way to monitor your replication lag. And then configuring backup storage redundancy. So this is for scenarios where you say, hey, our application is very constrained. Let's say we have your tight budgets. You don't want to have an additional copy of your primary and secondary and pay for the additional replica. The least that you could do is enabling the geo redundant storage redundancy type for the backups. So that way the backups get replicated through Azure storage. It has a higher RPO, greater than 1 hour, but at least you have one fallback option rather than not having anything. So this is something that you can explore as the last option for having geo redundancy enabled when you don't want to pay for the secondary at all. So this is something for those scenarios where uh, you're extremely constrained with cost and you want to see the available option. So the option would be geo restores. Right. And then we also highly encourage to frequently execute disaster recovery drills. So these are something that you do it in on a schedule basis. As you do disaster recovery drills, there are no data loss that's involved because you do planned failovers, which means you will have full data synchronization, but you will execute the DR drills, and it will also give you a sense of all the dependencies that you have to take care, so that way you're more prepared in an actual disaster recovery scenario. All right. With that, let's get into another checklist, which is for outage recovery guidance. Uh, think of this as not a checklist, but as a guidance of what you need to do when there is an active outage, right? And here's the workflow, right? As a customer, you would be, let's say you're logging into the portal and you see one of this banner, right? It says there is an outage in a particular region. You get notified in multiple different ways. So one is the portal. Let's say you start creating a support case. We notify you even in the workflow saying there is an active incident that's going on. Go ahead and monitor what's going on there, right? And also service health, like Azure Service Health gives you a neat view of all the regions that are healthy on if there are any regions that have degraded status. So you get to see all that in the service health page. If you have configured email notifications, then you also get alerted when any of these outages happening actively, and you get alerted saying there's an active incident that's going on, right? And when these things happen, so let's say a disaster is happening right now, what options do you have as a customer? Two options. One, you can, if the application is susceptible to some SLAs, and you have an SLA saying it is acceptable downtimes in terms of the RPO and RTO for the business needs, you can choose to wait, as in wait for the situation to mitigate, wait for the situation to self-heal, or for the Azure engineers or for the service providers like us, where we go and mitigate the incident as soon as possible. So that's an option that you can take. But we have also seen real life examples where the mitigation does take longer, or you have a stricter SLAs for the application to meet. In those cases, you can invoke the option of saying failover. So this is a decision that you take when you decide that, hey, I have to meet my application's RPO and RTO needs, so let's decide to failover. And when you decide to failover, there are two options that we suggest. One is planned failover. And we highly recommend to start the failover in a planned failover fashion. So the reason why we recommend you to start with planned failovers is there are cases where we have seen is the outage could happen at different layers within the stack. If the outage is purely at a control plane or on some dependent services, let's say identity, Azure recovery, Azure Active Directory, or let's say Azure networking, which are intermittent, this definitely signifies that this is happening at a control plane layer, but nothing is impacted at the data plane layer. So we recommend that, hey, monitor your database status. If it is online during the outage, which definitely indicates that the data plane layer is intact. And what you can do at these situations is you can start a failover in a planned fashion, which means we do full data synchronization. There is absolutely no data loss, even if you fail over to a geo region, because we make sure that before we complete the failover, we wait for all the data to be synchronized on the secondary, and then we open up the database at the secondary to become primary. So that's option one. And what you can do if that fails, then the last option, which is the last resort option, is doing an unplanned failover. At this point in time, you're definitely looking at some amount of data loss. So this is something that you'll have to exercise with utmost caution, making sure that you understand the consequences of the data loss, not just the data layer, and then talking to your application teams and all the dependent teams and the downstream systems on which that depend on this database. So this is a careful call that you take once you assess that the outage has passed a significant time and planned failovers are not succeeding. So you now are left with this last option where you take a decision to do an unplanned failover and potentially look at data loss, right? And the reason why we call it as potential is it all depends on how much of data that has not been replicated from the primary when the disaster struck. It might very well be possible that your secondary was all caught up, primary was pretty much idle at that point in time, and that's how you might even look at no data loss. But this is something that cannot be guaranteed because it's workload specific, right? And the last option is geo-restore. Let's say you didn't have set up disaster recovery through geo-replication or failover groups, you still have that option of geo-restore if you had enabled the backup storage redundancy. So this is something that you can explore. All right. And then we also gave you some instructions on what to do as you go through this recovery, like updating connection strings. So this is needed if you are doing active geo-replication, configuring firewalls, looking at logins and making sure that those logins and users exist on the other side. Telemetry alerts, these are something that you would have set up normally on primary, but we encourage you to take a look at these alerts and make sure that these exist on the secondary as well, and some of the other settings like auditing and so on and so forth. It's a living document, so if you have any feedback in this doc, I'm sure we might have missed some checks here, so please feel to create a GitHub issue, send it across my way. I get notified if anyone creates a GitHub issue on this one, so I'll make sure that those feedback is incorporated here. All right, with that, let me get back into the slide. I think I pretty much talked about the recovery guidance as well. I think that's all I had from a content perspective. Let me quickly check. Julie, are there any questions in the chat?
No, there's no additional questions over here. Anybody else have any questions? Yeah, just put them in the chat. Very good resources at the end. Yeah.
Yeah, I can also paste those links in the chat if that's convenient. But yeah, I think, Julie, we can work on getting this deck out so that participants can get this deck too.
That sounds good. Well, thank you very much for the presentation and your time for the user group. Very well received with those who attended. So thank you, Rajesh.
Thank you. Yep. Thanks, everyone.
We do have a recording, and I will work on getting that uploaded to our YouTube channel.
All right. Yep. Thank you. Thanks for the opportunity.